Dear colleagues, my name is Kateryna Pasichnуk, and I am glad to take part in the 6th International Workshop on Computer Modeling and Intelligent Systems to present a study of temporal and recurrent neural networks for CO2 emission forecasting. According to the Scripps Oceanographic Institute, last year the concentration of carbon dioxide in the atmosphere for the first time reached the maximum level, 416.43 parts per million. This number unfortunately increases every year. Therefore, control and forecasting of this indicator is necessary for timely mitigation of the consequences of climate change. Considering the urgency of the problem, it was decided to make a comparative prediction of the level of carbon dioxide in the atmosphere for 2023 based on recurrent neural network and temporal convolutional neural network, and also determine which neural network forecasting methods from the selected ones showed the best results. It is crucial to mention that a perfect forecast is impossible due to the presence of a large number of factors that are difficult to estimate with a high percentage of accuracy. Therefore, instead of expecting an ideal forecast, it is more important to have enough knowledge in the area of existing models as well as understand their appropriate application. Since the forecast depends on the past data, its reliability and accuracy will decrease in proportion of how far into the future the task of calculating is. The accuracy of the forecast and the costs of its implementation are interrelated. Factors such as its purpose and data availability play an important role in determining the desired level of accuracy. On this slide, you can see how the neural network forecasting models were constructed. Software implementation, training of neural networks, obtaining graphical and numerical results were performed in the Jupyter Notebook application. The Mauna Loa CO2 dataset was downloaded from the Scripps Institute of Oceanography and includes monthly atmospheric CO2 concentration values in parts per million from 1958 to 2022. On the first figure below is shown the CO2 concentration in the atmosphere since 1958. The second one represents the trend, seasonal, and residuals components. Let's move forward to the creation of a temporal convolutional network forecasting model. After the process of setting up the functions for the training and the series of manipulations with the parameters of the neural network, we got a graph with a forecast based on the TCN model. According to the results of the accuracy criteria, this model can best predict the level of carbon dioxide in the atmosphere in the upcoming years. We managed to achieve the ideal average absolute percentage error and symmetric mean absolute percentage error equal to 0.1%, as you can see in the table 1. On this slide, we are illustrating the creation of a prediction model based on a recurrent neural network. The learning process are similar to the TCN model, but as for the accuracy criteria of the model, they significantly differ. As you can see in the table 2, recurrent neural networks should not be used for forecasting CO2 level for the future years, since the symmetric average relative error indicator is equal to 0.17%, and the coefficient of determination is almost a tenth worse compared to TCN. In order to visually present the effectiveness of the researched methods for solving the problem, the results of the accuracy criteria of forecast for each of them were collected and compared in the table below. The summary table contains the metrics of forecast accuracy criteria that were used in the work, namely mean absolute error, mean squared error, mean absolute percent error, and symmetric mean absolute percent error. The last step was a creation of a forecast of the level of carbon dioxide for the year of 2023. After comparing all the results of forecasting methods used in this work, Our forecast of CO2 concentration in the atmosphere for 2023 will be based on the temporal convolutional neural network because it gave the best results. Input parameters for creating a forecast for 2023 are copied from the TCN model. You can see the result of the forecast of the level of CO2 in the atmosphere for 2023 on this figure. On this slide, you can see the table that contains the numerical indicators of the level of CO2 in parts per million corresponding to each month of 2023. Unfortunately, the level of carbon dioxide is constantly increasing. To prevent the consequences that might happen because of this problem, we all have to take a serious action to decrease the level of CO2. With the help of a customized forecasting model based on a temporal convolutional neural network, forecasts can be made for several years ahead. In the end, it is worth summarizing the results of our work. The results show that temporal convolutional neural networks outperform basic recurrent architectures in a wide range of sequence modeling tasks. The advantage of the artificial neural networks used in this work is that they provide a methodology to approximate the real data. This work can be useful in the future for solving the problems of excessive amount of carbon dioxide in the atmosphere. The prediction model based on the TCN can be optimized due to better setting of hyperparameters. This method is more complex and takes more time but can show significant improvements in the prediction results. Thank you for your attention.